Okay, so hopefully you had a good weekend. Today we're going to take a look at the unit circle and start developing that idea. So we're going to be using our knowledge of those special right triangles that we talked about on Friday, along with this idea of putting these angles in standard position and how that affects what we call sine, cosine, and tangent, to create our unit circle. The goal of this is going to be able to take any of these angles around the whole circle that have a reference angle of either 30, 45, or 60 degrees and find those trig values fairly quickly. That's going to give us a common place to talk about these things. It's not like I need you to memorize them, but in order to find them quickly, we can actually show that if we can find them quickly, we can use those values to help us understand this trigonometry going forward. So the first thing, let's just take a quick look at what we talked about on Friday, which was those angles in standard position. And so the biggest things here were that we have our initial side along the positive x-axis, we travel through some angle of rotation, and we have our terminal side. Now in this case, that doesn't really matter if that angle's between 0 and 90. It can be bigger than 90, it could be bigger than 360, it could keep going around this circle multiple times. Positive angles are always going to open in this direction, counterclockwise. If I open the angle in this direction, I'll have a negative degree measure, and that's fine too. So from there, we talked about how we have reference angles. And so just as an example, if this is 140 degrees as our angle, our reference angle is going to be the angle that it takes to get to the x-axis. In this case, because the x-axis is 180 degrees, I would know that the reference angle from 140 to 180 is 40 degrees. And so rather than using the 140 degree angle to define sine, cosine, and tangent, we're actually going to use this 40 degree angle. And from there, our definitions for sine, cosine, and tangent don't change that much. We still can make a right triangle out of this. And when we're defining things like the sine of an angle, we're still just looking at this opposite side over the hypotenuse. Or for something like cosine, we'd have our adjacent side over our hypotenuse. Now the big difference is the direction that we're going matters. When we stick to angles between 0 and 90 degrees in the first quadrant, all of our numbers are positive. We go in the positive x-axis or the positive y-axis. Now that we're in, for example, the second quadrant, this is the positive y direction still. So here the opposite would be positive. But since we're going this direction, the adjacent would be negative. So while sine of this angle is a positive number, cosine is going to be negative, and tangent is going to be negative. And so it just depends on which quadrant you're in. I don't worry too much about memorizing what they're going to be, but if we look at this and say, oh, well, that x value is clearly negative, I'm going to know my cosine is going to be negative as well. Next thing we talked about on Friday was going to be these two special right triangles. Hopefully you've had some time to look at these. You're starting to make sense where those come from. If we start to think about how we can use that information combined with this kind of definition of angles in standard position, what that lets us do is to find sine, cosine, and tangent values for basically any angle that has a 30, 45, or 60 degree reference angle. And so just as an example, if I wanted to find the cosine of a 210 degree angle, I have all the tools to do that now. So we could start off by drawing our angle in standard position. I'd have my initial side at 0. Because this is 180 degrees right here, I know 210 is just a little bit past that. I'm not going to go ahead and draw that in because that's just going to get in the way. But the big thing here is that I would now have a reference angle, or reference triangle even. So if this is 210 degrees and this is 180 degrees, my reference angle has to be that 30. It's just the difference between those two. From there, if I go back and look at my 30 degree triangle, I see my hypotenuse is 2, my short side is 1, and my long leg is the square root of 3. I can move that over here, the same idea. Hypotenuse is going to be 2, short one is going to be 1, and the long leg is going to be the square root of 3. The only difference, now that I'm at 210 degrees instead of just 30 degrees, is that these numbers are now negative. This one goes to the negative direction in x, and this one goes to the negative direction in y. And so for something like the cosine of 210, where I'm looking at the adjacent over the hypotenuse, I'd just have negative square root of 3 over 2. Now you'll notice that's the exact same number we got for cosine of 30, just with a negative sign in front of it. You're only going to have the same exact numbers for any 30 degree reference angle. The only change is going to be the sign. And by that I mean the positive or negative sign. If I wanted to find the sine of this 210 degree angle, I'd notice the same thing. Here we have opposite over hypotenuse is negative 1 over 2. And if you recall from before, the sine of a 30 degree angle is just positive 1 over 2. The only thing that changed is now it's negative. We can do the same thing for tangent. And if you recall from a couple of days ago, the tangent of 30 degrees is the square root of 3 over 2. And that's just what we get if we take 1 divided by root 3 and rationalize it. It's actually going to be the exact same value here because now I have a negative divided by a negative. And as we know, two negatives are going to make a positive. So I'd have negative 1 over the negative square root of 3. And rationalizing that is going to actually give me a positive square root of 3 over 3. And so some of these stay the same. Some of them change signs. Again, I'm worried more about thinking about what the x and the y values are. Now, kind of to organize our thoughts and help us learn these values and understand these values a little bit better, we have what we call the unit circle. And so the unit circle, pretty simply, is just a circle centered at the origin, and its radius is 1. And so that gives us a couple of key points here. For example, this is 1, 0, this is 0, 1, and this is negative 1, 0, and 0, negative 1. So just in the xy plane, those would be the points, because the origin is, of course, 0, 0, and just traveling 1 unit in either direction gives me those points there. Now, the biggest difference between what we just did and this new interpretation with the unit circle is going to be the radius. Because we said the radius is 1, our special right triangles that we used are not actually going to fit in there. We have a radius of 2 units here and square root of 2 units here. And so all we're going to do is simplify or scale down these triangles. So here I'm going to divide all of these by 2, and now I'd have 1 as my radius, which is what I want, root 3 over 2 as the long side, and 1 over 2 as my short side. Here I get a little bit more tricky, but it's not that bad. I'm going to divide all of these by the square root of 2. This is going to be clearly 1 now, but I'm not going to leave these as 1 over the square root of 2. Instead, when we rationalize those, we're going to get the square root of 2 over 2. And that's going to be the same for both sides. That is the same thing as 1 over root 2. It's just rationalized. And so what you'll see for these triangles, when we think about them in terms of the unit circle, we're going to have these numbers instead. They're the exact same triangles. They still have the same ratio. If I think about, for example, the sine of a 45 degree angle is opposite over hypotenuse. Well, now the hypotenuse is just 1, so I know the sine is just the square root of 2 over 2. And as we saw from last week, it's the exact same thing. So now we want to apply that to the unit circle. So I'm going to get you started on this, and then I'm going to let you pause or actually stop this video and pick up with the next video after you're done with this. But the first thing I want to do is go around and label all the angles. And so we've got our 0, our 90, our 180, and of course 270s down there below there. And in this first quadrant, we have our 30, our 45, and our 60 degree reference angle. For all the other angles, we have to think about each of them, again, being a 30, 45, or 60 degree reference angle. So for example, if I'm interested in filling out this one, which is a 45 degree reference angle, I need to think about, well, what's 45 degrees before 180? And that's 135. If I go down here into my third quadrant, and I want to fill out, for example, this one, well, that's 30 degree reference angle, so 30 degrees past 180 is 210. And then maybe I'm interested in filling out this one. Well, that's 60 degrees before, not before 0, but before 360. And so 60 degrees before 360 is 300 degrees. So this would be a good point. Pause that video, fill in the rest of those angles, leave the circles blank. We're getting to that after break. And then I'll come back and we'll talk about what these things are on the outside. Okay, so hopefully you have your angles filled out now. I'm just going to look at this first quadrant first, and we'll talk about how we get these angles. We already talked about where these come from. So this is the point 1, 0, and 0, 1. Now, to fill in this first one, I have a 30 degree angle, and so I'm going to want to look at my 30 degree reference triangle. So I know the long side is root 3 over 2. The short side is 1/2, and of course the hypotenuse is 1. And so I'm going to go ahead and draw this one in here for now. and label my sides. You certainly don't have to draw it in, but I think it's helpful for the first ones. So all this is here is just the xy coordinates of this point. It also has some other representations we'll talk about in just a second. So if I go over root 3 over 2 and up 1/2, I get to the point root 3 over 2, comma 1/2. It's just x and y values like we've been doing forever. If I pick a different one, let me go ahead and erase this real quick. Let's say, for example, I pick the 45-degree angle now. I know that from looking at my special right triangles, both the x and the y are root 2 over 2, while the hypotenuse is 1. So again, you don't have to draw this in, but it can be helpful. I can go ahead and label my hypotenuse as 1, and I know both legs are root 2 over 2, root 2 over 2. And so the coordinates are going to be root 2 over 2 and root 2 over 2. Finally, if I go to the 60-degree angle, I'm going to be using the same triangle I used in the first one, only this time I'm going to be using it in the other orientation. So hypotenuse is still 1. Now I have the short side here, which is 1/2, and the long side is root 3 over 2. And as you'll notice, the points are actually the same values from our 30-degree angle, just switched around, which makes sense when you think about where we got those from. So that's the first quadrant. Those are the only numbers you're ever going to use on this unit circle. The difference now is that when we switch sides, when we go down, for example, into the second or third quadrant, some of these are going to have different positive and negative values. So if you think about this, in the second quadrant, when I'm going to go to the negative x-axis, my y values here are going to stay the same. My x values are just going to switch sides. Down in the third quadrant, they're both going to be negative, but they're going to be the exact same values. So I also have here the third quadrant, I believe. We'll just take a look at one of these. Let's just do the 30-degree angle here. And that is a 210-degree reference angle. And again, I like to think about this by drawing my triangles in. So I know in this orientation, my radius or hypotenuse is still 1. This is the short side, so I know that's 1/2. And this is the long side, so I know that's root 3 over 2. The only difference now, both of these are negative because I'm going to the negative x-axis and the negative y-axis. And so my point here is going to be negative root 3 over 2, comma, negative 1/2. Again, you'll notice the exact same values there as with our 30-degree reference angle up here, just that they've changed signs. So take a few minutes, work with your group, fill out this unit circle. You can draw on it. I've given you one more copy on the back, so if you draw on the first one and it's a little too messy, you can certainly just fill out a new one on the back. But take your time on this. The whole goal of this unit is not to have these memorized. It's to understand where it comes from. And so really take your time in understanding that part.